Jeff. Certainly appreciate everything that you guys do. Oops. We definitely have a mutual admiration society going here. I consider the Georgia Aquarium almost my second home at this point. The support and collaboration that we've had here has been fabulous. And what I'm excited about this morning is being able to report to you some of the results of the research that the aquarium has promised it would support, promised it would do, and we're going to deliver on that promise. Before I talk about the aquarium, though, I want to tell you a little bit about where I'm from, just so you orient who is this guy, what's he doing here. Mote Marine Laboratory started a little over 50 years ago as a tiny little field station down on the west coast of Florida by a wonderful woman named Dr. Eugenie Clark. And it was called the Cape Hayes Marine Lab back then. And believe it or not, Jeannie is still with us. She'll be 85 the coming year. She's still diving. She's still an active scientist. She's a great inspiration to us. And she's known as the Shark Lady. She's written many books about sharks. So she started the research program that became this facility. Today we are one of the world's largest independent nonprofit research and education laboratories. And we have about 250 employees and a budget of about $20 million a year. So from little things, great things grow. And we are in Sarasota, Florida. And our research division comprises 7 different centers. So we do things other than sharks. We do everything from coastal ecology, red tide research, fisheries, marine mammals, such as the belugas behind us, coral reef, aquaculture. But I'm here to talk to you about the Shark Research Center. And these are just some little vignettes, if you will, of the kinds of research that we do. Our scientists. So that's a little bit of a background. This guy, not this guy, but this guy. That's not me. My Speedo days are long over. I think everybody's Speedo days should be over. This guy is a species of shark that I wanted to work on. I saw my first whale shark about 30 years ago in Florida Keys. I always wanted to work on them, but they're so elusive and relatively uncommon that it was difficult to build a research program around them. But they are the world's largest fish, the world's largest shark, and they are, thank goodness, a plankton feeder, so you can swim in them pretty safely. Unfortunately, this is also a sequence of whale sharks that we don't like to see. In some parts of the world, whale sharks are still hunted for food. In the Philippines, in Taiwan, in Indonesia, in India, people view this animal as a great source of food. You can't blame them. It's a huge animal, and they call it tofu shark in some parts of the world. So we don't like to see that in this day and age. We'd rather see this, which is right here in the Georgia Aquarium. Beautiful animal, doing very well, and in this case, these animals saved from the fate that you saw on the previous slide. A little bit of background on whale shark biology. They are found all around the world's oceans, in basically all tropical and subtropical areas, except interestingly not in the Mediterranean Sea. And the stars you see there are places where they're known to aggregate, where more than just a couple of animals come together at different times of the year. Most of these places, we're talking about maybe a dozen animals, like what Bruce said, 7 or so. People get very excited to see 7. Places like Nagaloo Reef in Western Australia and off the coast of Belize in Central America have been well known as places to see a few whale sharks at a time. The place we're going to go to, though, as we've been looking, is on the Yucatan coast of Mexico, where the Gulf of Mexico meets the Caribbean Sea. And here's that location. The Gulf of Mexico is a very deep body of water out in the middle. The Yucatan Peninsula here, of course, Florida in the U.S. This is the Yucatan Channel between Mexico and Cuba, and the Caribbean up here, the Gulf here, and the country of Mexico. And the spot we're going to work is that northeast corner there, where the two bodies of water meet. Here's a map of this area. The resort town, the city of Cancun, is down here to the south. These little Mujeres, Huelva Mountains here. Much of this is undeveloped and very rural. Up here is the lagoon called Laguna Yalajao. And then here's the special little island that we work off of. Isla Holbox, Holbox, pronounced Holbox. It's a Mayan term for means black hole because of springs that are in the area. I'm going to show you some scenes from this town here. But the big stippled boxes are the federally protected natural areas for fisheries for resource management. So keep in mind where the boxes are. It's going to have an effect on the sharks. Now, to understand a little bit about why the sharks are there, we have to go back and look at a little oceanography of the region. As water moves up through the Western Caribbean and squeezes through that Yucatan Channel here, it gets compressed and rotating clockwise, which pulls water away from the Yucatan coast. That pulling water away has to be replaced by something else, and that something else is very deep water that's very nutrient rich. That deep water is cooler, so if you look at the temperatures on the eastern side of the channel, they're up in close to 30 degrees Celsius. But on the west side, it's 4 degrees Celsius difference, which is significant in terms of seawater. So a little bit cooler right here, and full of nutrients, full of stuff to make plankton grow. And you can see that in the satellite image of chlorophyll, which is the plant plankton. And with phytoplankton that comes here in the summertime in particular, there's animal plankton called zooplankton, and the animal plankton is the food of the whale sharks. So thus come the whale sharks. And there's probably about a 25-foot boat, and you can see some animals there in that shot, that aerial shot. Well, as Bruce said, this ain't nothing. Take a look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And one human having fun. You can swim with them. And a big ecotourism industry has grown up around these animals. But that really ain't nothing. Get ready for this picture taken from an airplane at about 400 feet. And you see all the little dots? Those aren't tadpoles. Those are all whale sharks. 76 in one shot. Clearly, we have a lot of whale sharks in this area. And the interesting thing was I worked in that lagoon inside the island for about 10 years and had no idea that the whale sharks were out there working on different species. And it wasn't until the last year that one of the fishermen said to me very casually, "You know, Bob, you do know that every year after you leave, we have all these whale sharks out there." Okay? What? And so, one thing led to another, and that's what led to this project. The town of Holbox, a very quaint town, where the streets are paved with sand. There's no boon to that town is going to change it, because here was an article that was in the New York Times last month about our little town of Holbox. The whale shark has affected the town greatly. You see signs of whale sharks everywhere. It was basically a fishing community having troubles because the fisheries have been depleted, were not sustainable. So now all of the fishermen have converted over, most of them, converted over to become ecotourism guides to take people out to see whale sharks. And the Mexicans, to their credit, have developed very stringent guidelines for contact with the whale sharks. You cannot touch them. Only 3 people in the water at one time, two tourists and a guide, and so on. I think it's working fairly well. My concern is that they're opening this thing up to too many boats doing this, and at some point I'm concerned that they may affect the behavior of the animals. But our research has been designed to try to feed into this management process and guide the Mexicans in terms of the management of this resource. Well, from a scientific basis, I had basic questions. How many animals were there? What sex and size? When? Why are they at the site? Where are they coming from? Where are they going to? Very simple questions. And to address these questions, we have brought to bear a suite of different methods. I'm not going to go into all these, but various things to try to characterize the population there at the Cold Wash. The one that I want to focus on is tagging, because we realized early on we had so many animals, there was no way for us to keep track of animals just by looking at scar patterns or dot patterns, which has been used in other areas. We had to get tags in these fish to be able to count them. So we used a visual tag, a number tag that's put in the shark to identify a particular animal, and a satellite tag, an electronic tag that I'll tell you a little bit more about. And this shows you the visual tag underneath the dorsal fin of one shark, and then the satellite tag here. The first thing that we realized was that the sharks were distributed out here in fairly shallow water, only about 30 to 60 feet deep on the bank. A group north of Cold Wash, another group north of Contoy. This gap appears to be real, and we're not quite sure why that is, but nevertheless, this is where animals are found. Notice where the park boundaries are. The sharks are not staying in the park. So they are protected in Mexico. You can't fish for them, but clearly Mexicans want to expand the boundaries of the park and include this whole area for blanket protection. As far as the tagging work, we've not tried to show you a whole lot of data this morning, but this is one summary. We have been tagging somewhere close to about 200 animals over the last 3 years once we had a sort of a proof of concept here. And now we've got over, actually this number's gone up, this tagging is already commenced for 2007, but well over 550 animals visually tagged. The sex ratio is about 2.5 males to female, which is actually more females than most of these other sites. So we have always wondered if there's some reproductive activity going on. They're both mature and immature animals of both sexes. And the size range in the tagged animals is about 2 meters to 10 meters, about 7 feet to 32 feet or so in length. But larger animals have been observed and documented as having been tagged up to about 42 feet long on the site. So we have everything from not real little ones, but 7-footers all the way up to over 40. And using data from aerial surveys and from tag and resighting studies, we have a very rough estimate at this point that there's somewhere between 500 and 1,500 sharks at the site every summer. It's the world's largest aggregation of whale sharks that is known to science, no question about it. And the animals are there from May to September. They may just have some showing up in April, but generally May through September. Now, with all these tags out there, we've gotten resightings, especially in the Western Caribbean, places like down the coast, off Belize, off Honduras, down in Tila. Interestingly, we haven't had any tag resightings inside the Gulf of Mexico, away from Cold Wash. Lots, of course, back up in this area, but away from there, no visual tag resightings. So, therefore, we switch gears and we go to the satellite tag system. Now, this is a satellite tag. This is what we call an archival tag. It collects data and archives it within itself electronically. And then when it's ready, it sends the data back to us in the laboratory via a satellite. It collects data on light level, on depth, and on temperature. And when it's programmed to release from the shark, it breaks the pin right here electronically. It floats to the surface. This little guy is afloat. And there's a little antenna on it, and it starts beaming its data back to us via satellite and email. This is actually a tag shown on a different species of shark here, but you can see how it's applied with a pulse here. And people ask me all the time how the animals react, and it's nothing. I think it's like, what was that, a mosquito or something. But there's no, really, in most cases, there's no reaction whatsoever. I've been tagging sharks for 30 years, probably tagging about 5,000 animals. This is the easiest shark I ever had to tag into the big carpet. When we get really fancy, sometimes we try to go for a spot. But, so these things are wonderful instruments. Here is a little device that cuts the tether in case the animals dive too deep so that the tag is not crushed. They are marvelous technological tools that when they work, you're overjoyed, and when you don't hear from them, you're crushed. But we've had some results, and I'm not going to show you all the results this morning. Actually, tonight I'm going to give a longer lecture and go into a lot more detail. This is kind of what I call lecture light this morning. But some of the results from the satellite tag data, here's one that was put on the shark in Holbox, and it, what we call, popped up, released from the shark, and came to the surface and started sending its data right here. And then you go back through the data and recover all the points in between, where the shark had been, what the temperature was, what the depth was. So in 31 days, this animal moved 889 kilometers, but that's just from here to here, net movement. Actually, with all the other movements back and forth along this path, it's probably moving at a clip of about 35 miles per day when it was moving fastest rate. This was an immature male, 6 meters in total length. And interestingly, this tag came off and floated around out here for a while and ended up on a beach in Texas, where, believe it or not, a graduate student who knew what a satellite tag was went down and saw it and grabbed it, and we got it back. And the reason that that's so exciting is by satellite, you only get kind of summaries of the data. But when you get the tag back, you get minute-by-minute data of that animal's life over 31 days. Here's another one. Now, this one started the same place. Again, an immature male. But it went up here, did a little curlicue. And, of course, you only have dots in parts of the track, so you don't know the exact movements in between. So here's a place where it went from back off Holbox down south of Cancun. Apparently stopping off in the bars in Cancun over here. Of course, immature males know to do it. And then ended up below Cozumel and down here off these bays. So that one went into the Western Caribbean, very similar to some of the reports of our visual tags. I'll just show you one other example. This was a mature female, and she did something completely different. She went up, curled around, and then she went into the Florida Straits off the north coast of Cuba. And we do know that some sharks are there in October, November, which is when she was there. And then she started coming back. And actually, this animal, which was tagged last September, has been resighted back in Holbox. Was resighted at the very end of June, and she appears to be pregnant. So we do get this. We get animals coming back to the site. We've had about 50 or more than 50 resightings of tagged animals back at the site, and there is some sense that they can navigate back to these areas. So what do we have here? Well, got kind of a mess. This is like spaghetti. These are a lot of some of the other tracks we've had, and clearly all we can say at this point is that from Holbox, which appears to be the kind of capital of whale sharks in this part of the world, in the summertime, the animals disperse in all directions. They go into the western Gulf of Mexico, they go into the Caribbean, and they go into the Florida Straits. So there's reason to believe that this aggregation represents a population that's much bigger than you saw from Holbox, that is basically serving the entire Gulf of Caribbean basin and possibly even to the Northwest Atlantic. Now, the dive data are really fascinating. We have known through the work of others that the whale sharks will go on deep dives when the water becomes deep. This is a record from a 7-meter female, and it shows that the daily minimum and maximum depths and the maximum and minimum temperatures that she experienced on each day for a 2-month period. I think that this is actually a pregnant female who's come back. Up here, she's still on that shallow bank in Holbox, but as soon as she gets off the bank, she starts making these long dives so that she goes down to 500 meters below and then down here 1,000. And temperature's getting cold, and she's some days, and notice every day she's back up at the surface at least sometime. This is not a dive profile, and this is just where the range of depths and range of temperatures that she's been. So you get down to this point right here, and that is actually a record for the species. Over 4,500 feet, close almost approaching a mile in depth, and temperature of 4 degrees Celsius, 39 degrees Fahrenheit. Very cold water, very deep dive tag was found at Tyson's Beach. So we get all the minute-by-minute data. This shows the dives with a little bit better profile. This one cuts off here because that tag was an earlier generation and didn't record below 1,000 meters. So it probably went a little deeper. But you see that the duration of the dives is about an hour. They don't go down and level off and stay there. They go down and come back up. So diving into this cold, deep water, and then coming right back up. And when we compare the track and our dive record here with the bottom topography, so as the animal goes on this trace here, we're going across this way. So there's point A is here. That's the edge of the shelf. You see that when it gets to point A, it starts doing these deep dives, approaching the bottom. So we think the bottom is somewhere in this range. And then it has deeper water to go, so clearly it could go deeper, but it doesn't. It does some deep dives. And then as the bottom came up on the west side of the Gulf, we had the animal staying closer to the surface. Finally, and then it does some deep dives again, not close to the bottom. So it obviously raises the question of what is this deep dive for? Is it for feeding? Possibly, but when you look at the food content down there in the Gulf of Mexico, there's nothing really that special there. So it's questionable whether it's for feeding. Parasite removal is a shake. Parasites shake things like remoras. Seems awfully extreme to go down that deep to do that. The water temperature actually levels out at 800 meters, and so if they're doing that to get rid of parasites, maybe it's a depth thing, but that remains to be seen. These are all hypotheses. The possibility of temperature regulation. These are big animals, spend a lot of time at the surface in subtropics and tropics, so they build up a lot of body heat, so maybe this is a way to go down in the air conditioning and cool off for a while. And kind of along with that is the idea that maybe this is a resting phase where they've done all this swimming, all this migrating in the open ocean against currents and everything else, and they just kind of zone out for a while, do a slow glide, and then they get to a point where, okay, time to kick back everything on again, and they go right back up to the surface. We actually see that behavior in some other shark species that have been, say, caught on hook and line. After they're released, they do that sort of thing. So this is a possibility. Well, in addition to the tagging work, we've done feeding studies, both in the wild with Mike. This is Mike Maslanka from the aquarium here, and Dr. Phil Moto from the University of South Florida, who's a feeding specialist, shark feeding specialist, and in the aquarium as well. We've been able to combine our observations and studies in the wild with what we can see in the aquarium here, which makes for a very powerful scientific approach. In the wild, we do things like look at the mode of feeding and measure the mouth gape in order to understand how much water they're bringing into their mouths to get how much food they're filtering out. These animals are filter feeders. They go along the surface and strain water out, sometimes below the surface as well. Sometimes they hang vertically and go after very thick patches of plankton. So how do they actually get these minute organisms out of the water that for such a large animal? Well, here in the aquarium, we've had this incredible opportunity to be able to get in the mouths of the live animals and look at this apparatus that they have here. And with the unfortunate deaths of Ralph and Norton, we did have a tremendous opportunity to be able to look at the structures that involve feeding. And they have these very strange feeding pads, for lack of a better term, almost like a sieve, or it reminds me of the filter that you have in your air conditioner. And with this beautiful configuration inside, I'll show you another picture of that. I don't know if you can see that very well, but when you look very close, these are all little openings in these feeding structures. Now the openings, interestingly, are bigger than what most plankton runs. So how does a filter like this hold plankton back and allow the animal to feed? Well, what we think we've discovered is a kind of a new way of filtering in this animal. This is a beautiful drawing of the mouth apparatus and the gills whale shark. Water comes in through the mouth, goes past and through these filters, and then goes out over the gills. These are the gills where oxygen exchange takes place. So the feeding part comes first, then the breathing part after that. Well, again, if water is passing over this, how does the plankton stay behind? It seems like the whole thing would get all gummed up. This is how it happens, we think. The orientation of the feeding mechanism is at an angle to the way the water comes in. So water is coming in this way, and the filter pads are at an angle like this. When you put a filtration device 90 degrees to the flow, you get what's called dead-end filtration. There's particles, which could be plankton, coming in and going through with the filter. And what happens is they start getting gummed up, essentially, in the openings of the filter. Pretty soon you have a block situation. In this approach, which is what the whale shark uses, the water flow is at an angle to the filter. This is called cross-flow. I always want to say flotation, but it's cross-flow filtering. And in this case, the water is able to go through, go over the gills with oxygen exchange, but the particles, plankton, are retained behind, and they also move back toward the end of the structure, which is perfect because it gets the food concentrated in the back of the throat. And when you get enough food back there, you see them do a little bit of a kind of a cough or a swallow, and then they continue on. Now, using the measurements that have been taken by Mike and off Holbosch and by Phil Moda, and some of the calculations, we're saying that off Holbosch that these animals are ingesting through this mechanism about 9 pounds of plankton per hour. Doesn't sound like a whole lot, but when you add that up over hours and hours in each day of feeding, that's a lot of food. So, to sum up some things we've learned so far, obviously from May through September, there are hundreds, perhaps over 1,000 whale sharks that use these waters as a major feeding area. They're feeding on very dense concentrations of plankton that is fed by an upwelling, and they have a unique filtering method that probably has application in engineering, sort of what we call biomimicry, mimicking what these animals are doing for engineering applications. We haven't seen any reproductive activity yet, but we think it may be occurring in the area. After the summer feeding period is over, these sharks are dispersing virtually all directions into the Gulf, Caribbean, and possibly the Northwest Atlantic. When they have access to deep water, the sharks will dive at very deep depths. We think at this point, we're not sure, perhaps more for temperature regulation and metabolic needs and feeding. And the great news of this story is that the population in this area may be good and actually be increasing. Why? Because they're not hunted themselves, and their food is not endangered. In most places around the world, sharks are severely depleted, 75 to 99%, and their food sources are often depleted as well. This is a big animal that eats plankton, is not itself hunted, so we think we finally have a happy shark story to tell here. Okay, at this point, I want to ask our AP guys to switch over to a 2-minute video. We're going to just look at some of the work we're doing. This is shot by Dr. Bruce Carlson. This is actually the video that runs here at the aquarium. But it demonstrates. And Bruce has been down there with us. He's helped us with our studies. He's been an instrumental part of it. Been a guide and a great friend, and is an excellent photographer. These are the subtitles, of course, that run in the aquarium that we exhibit. I notice the water is relatively turbid because it's so full of plankton. This is not a very clear water reef type environment. The animals are there for the food, so the visibility is restricted. There you see a tag on the end of the tank hole. Going out, approaching the street. There's the tag. Okay, there's the tag already applied. These tags last on the animals at least a year. Our Mexican colleagues started measuring the dorsal fin base length, because we can correlate that with total length. You can see if you look closer, there's a satellite tag already applied. He's going underneath now to tell what sex it is. With sharks, you can tell what sex it is. Plankton toes show what they eat. This is very typical tropical species of plankton. And this is what they're eating there. We've also taken little biopsy tissue samples. These are worldwide genetic studies of whale shark populations to understand the relationship between this population and, say, ones in the Pacific. This is setting up one of these satellite tags now. We programmed it with a laptop. Here's Battlestar Galactica coming at you. Let's see, there's the satellite tag. The lady with the duck fins there, that's so adorable. Say goodbye. I'll put it over. So we can go back to these slides. Each one. Lots of little switches here. As I think Jeff or Bruce mentioned, we are leaving tomorrow morning for the next expedition. We'll be down there about a week. We have people coming from the aquarium. We also have this film crew coming. And this will be the first of 3 trips to the site this summer for us, so we're ready to go. I just wanted to say that in a project like this, there are many, many people to thank. And I can't name them all, and I probably left some people out. But I really want to thank, of course, the Georgia Aquarium for the support. Without the aquarium's investment in this project from the beginning, and without their encouragement and the collaboration and friendship, we never would have gotten this information, which is really helping to lead the field in terms of understanding the species of this animal. So, just want to say thank you to the aquarium, and thanks to all of you.